Hello everyone, now I'm recording homework 9 of probability and scale-casting process. Now let's look at the first question. Suppose WT is the winner process discussed in class. Now let us define xt equals w of t plus 1 minus w of t. First, draw the couple of samples of xt. The samples of xt is generally like this. For a fixed t, x always is a normal distribution. And let's look at the second sub-question. Find ext and rt and t2. Ext is w of t minus 1 minus t plus 1 minus w of t. W of t equals the limitation of xt, so w of t plus 1 equals to the limitation of x of t plus 1. And we separate them by the minus for this one and this one. They all equals 0, so ext equals 0. And now let's look at rt1, t2. rt1, t2 equals expectation of x of t1 times x of t2. We replace xt1, xt2 with this equation, so we could get it like this. And then we use the butterfly cross to expand it. Then we could get 4 terms. And then we replace each term with the limitation of xt. Since expectation of wt squared equals alpha t, and rt1, t2 equals alpha mean t and t1 and t2, so we could replace the 4 terms with the form like this, and we extract alpha to the outside of the brace. Then for this equation, it has 4 consequences based on different conditions. The first one, when t1 is less than t2 minus 1, rt1, t2 equals 0. And when t1 is greater than t2 minus 1, less than t2, rt1, t2 equals alpha times t1 minus t2 plus 1. And when t1 is greater than t2 and less than t2 plus 1, alpha t1, t2 equals alpha times t2 minus t1 plus 1. And when t1 is greater than t2 plus 1, alpha t1, rt1, t2 equals 0. So, in general, rt1, t2 has 2 values. First, when absolute value of tau is less than 1, it equals alpha times 1 minus tau absolute. And rt1, t2 equals 0 when absolute tau is greater than 1. Now let's look at the third question. Is xt WSS SSS Markov with independent increments, with uncorrelated increments, with orthogonal increments? Prove all your answers. So first let's look at whether xt is WSS. ext equals 0, it's a constant, and rt1, t2 is only a function related with tau, so xt is WSS. And since xt is a normal distribution with alpha, and xt is WSS, so xt is SSS. Now third, let's look at whether it's Markov process. xt is normal distribution, which means xt can be written as this. which is independent of t. It is a function only depends on random variable x, but nothing related to t, so the past has no influence on the statistics of now and the future. Therefore, xt is Markov process. And let's look at whether it's independent increments. Wt and Wt plus 1 is Wiener process, so they are also independent increment process. For any non-overlapping intervals, suppose Td less than Tc less than Tb less than Ta, just like this on the axis. Probability of W of T1 Ta plus 1 minus W of Tb minus plus 1 is less or equal to W1. WTC plus 1 minus WTD plus 1 is less than or equal to W2. For this probability, we could rewrite them just by separating it with a multiply here. We can rewrite it as the probability, the multiply of two probability. Now let's assume W1 equals x1 plus WTA minus WTB, and W2 equals x2 plus WTC minus WTD. So the equation above can be rewritten. This equation can be rewritten as probability of WTA plus 1 minus WTA minus WTB minus WTB times this part, the probability of this part. And WTA plus 1 minus WTA is XTA, and this one is XTB. This part is XTC, and this part is XTD. So we get the equation like this. Hence, xt is an independent increment process. Then let's check whether it's an orthogonal increment. Obviously, independent increments implies uncorrelated increments. So xt is a process with uncorrelated increments. And for expectation of xta minus xtb times xtc minus xtd, it can be rewritten as the multiply of two expectations as this. And we could put e of the two terms, put e in the brace. So we could write this one like this. And cos ext equals 0, so these four terms are, all of them are 0. So the value of this equation is 0. So xt is an orthogonal increment process. And now let's look at question 2. Let n be a Poisson process with parameter lambda, that is n the number of random points arrive in t1, t2, because k equals e to the order minus lambda t2 minus t1 times lambda times t2 minus t1 to the order of k over k factorial. Now define a new stochastic process as xt equals 1 if n is odd in 0 to t, and xt equals minus 1 if n is even in 0 and t. First, draw a couple of samples. So firstly, let's define t1 is 0 and t2 is t. So the probability of the number of random points arriving 0 and t equals k can be written like this. For all samples, epsilon I, when I is 1, 2, 3, and to n, the sample can be drawn like this. For all samples, epsilon x of 0 is fixed at -1. Second problem, find pxt equals 1. Pxt equals 1 means in 0 to t, n is odd, which means n is 1, 3, 5, 7, blah blah, which means the sum of Pn when n is odd. Pn, we could replace it with this equation, and so we extract e to the power of minus lambda t to the outside, and the sum of this part when n is odd is this part, and this part is equal to sine h lambda t. The third